going to pick it up with the second day that we had trig in here. We were looking specifically at using your definitions of trig functions. We picked up your reciprocal identities, which we talked about before, and we used a little bit before, but we pointed them out and drilled them in this time. We looked at Pythagorean identities, and we also looked at the quotient identities. Again, we mentioned them before. So this goes to memory. I don't know if you can see this or not, but it has to be memorized. We did take a memory quiz on it. It should make sense if you look at the top row. Sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. These are they're paired up exactly the way you normally write them. And when you look at the second line, you see all they did is they took these guys and they swapped places. So it's just writing the reciprocals in a different way. So you need to be able to write them in all ways. So all 6 of these reciprocal identities you need to be able to write down. Okay? Now, just to be able to use them, yes, you need to be able to do this. So find each function value. What is cosine of x if you know secant of x is 5 over 3? Well, what's the relationship between cosine and secant? Well, we just said it. They're reciprocals. So that means take this and turn him upside down. 3/5. Same thing over here. Sine, cosecant, they're reciprocals. If you want to know sine of x, you take your fraction, turn it upside down. We're going to let our negative rise to the top. Okay? That's all it is to find your reciprocal values. Now, you do need to know how your signs work, your SIGNs work with trig values. Very important concept here. So we use the little saying, all students take calculus. And we start in the first quadrant, and we rotate around in order of the quadrants, okay? So all is for all the functions. Students is for sine, and it's reciprocal now. So that does count for cosecant as well. Tangent counts for cotangent, and cosine counts for secant as well. Okay, so make sure you're including their reciprocal when you're doing this. But this chart is for positive values. So everything listed here is positives, positives, positives. So make sure that you're getting that. This is where things are positive. Let's just look at one of these down here at the bottom. We'll look at the middle. Determine the sine of the trig functions of an angle in this with this measure. Well, where is 300 degrees? This is 360 and this is 270. So 300 is somewhere down here. Fourth quadrant. Who is positive in fourth quadrant? Looks like cosine and secant are positive. So if you had to, you could tell me sine, cosine, tangent. And I realize that this is not the most sophisticated way to write this, but it will be effective for right now. So cosine and secant are positive, and the rest of them are negative. So that's the way it's supposed to be. If you are in the second, third, or fourth quadrant, 2 of them will be positive, and the other 4 will be negative. The only exception to that is first quadrant, everybody's positive. So let's see kind of how this works. I don't think you need another one of those. This is what we really need right here, is if you can take a description and kind of use process of elimination to figure out which quadrant you are in. So the way we did it in class is just set it up like that. And let's just think. And by the way, they're always going to use this greater than 0 and less than 0. Greater than 0 just means positive. Less than 0 just means negative. So sine has to be positive. Well, sine's positive in the first quadrant and sine's positive in the second. So third and fourth are out. So go to the second thing. By the way, one item will eliminate 2. Then you can go to the second one and eliminate 1 more, and you have your answer. So this thing right here, tangent has to be negative. Well, if tangent's negative, we can't be where all of them are positive, right? That's out. We must be in quadrant 2. Okay, So let's just do one that's a little bit interesting. Let's do this one down here at the bottom. Same thing, all students take calculus. So I know that sine is negative. Here we go, we got secant. My brain does not work in secants. Maybe yours does, but mine does not. So I'm going to think with its reciprocal. And he is positive because it's greater than 0. So sine is negative. Where is sine negative? If sine is negative, I don't need this one and I don't need this one. I would need the bottom two. So now let's use this. Where is cosine positive? This one. So I need quadrant 4. Okay, you can take that information and use it to help you solve problems. So you're going to use your trig definitions, and you're also going to use your knowledge of signs, your SIGNs, not your SINEs, and you're going to let that incorporate both those ideas to help you solve some problems. So suppose you got an angle theta that is in quadrant 2. So they were very nice, and they told you it's in quadrant 2. And it said that sine of theta is 2/3. Okay, you should know that sine is defined as opposite over hypotenuse. So from this picture, opposite is 2, hypotenuse is 3. That does not look anywhere remotely like a Pythagorean triple. So I have got to come down here and do 2 squared plus b squared, whatever letter you want, equals 3 squared, because hypotenuse is always over here by himself. So b squared equals 9 minus 4 is 5. So b is square root of 5. Now the thing is, where most students mess up is right here. You have to pause and think, did you go down or did you go left? Because direction makes all the difference in the world. We just placed this in the picture, in our diagram. That went left. So we need to note the direction. It is negative in this picture. You have to take the time to do it or all your answers will be off. So please, please, please put your SIGNs in your diagrams. So you could go right through with this and put all your trig functions in. You got cosecant and secant and cotangent. And then you're just going to rock and roll through this. Negative square root of 5 over 3. Tangent is 2 over negative square root of 5. That's so got to be fixed. So that's negative 2 square root of 5 over 5. Remember, go back to the original and flip that one. This one, when you flip it, you actually do create the mass. So negative 3 square root of 5 over 5. With more time, you'll be able to do it in your head. Yes, I'm moving a little quickly because I'm restricted to 15 minutes. Okay. Let's see here. I'm thinking you should be, like, I'll tell you what, let's do one more of these. If we are in quadrant 3, and we have tangent is 5 over 7. Here's our angle. That means opposite is 5. Adjacent is 7. I don't know my hypotenuse, and that is not a triple. So I've got to come in here and work this out. I really don't know what 25 and 49 is. 25 plus 49, 74. So square root 74 equals C. Remember, that's always positive. Don't pause. Think. Is anything left or is anything down? This is left and this is down. Yes, tangent was positive, but tangent was positive because these two negatives canceled each other. So don't be deceived. You got sine of theta, cosine theta, tangent theta. So sine is negative 5 over square root of 74, and you've got to fix it. And I'm going to be a bad girl, and I'm going to not do the reciprocal functions this time, just for the sake of time. These are one of those things that just, you get better with them as time goes on. You might need to still label your sides. Doesn't want to write, does it? Okay. If labeling the sides of your triangle helps you, then by all means do so. this is one of those, well, it's a pretty good skill to have in Trig. So I think we've done enough of those. Now, here we go again with memory. You have got to get these memorized. It may not be something, especially like these Pythagorean identities, it's not something we're going to use a whole lot right now, but come chapter 5, we definitely will be using those. I will show you a little device here in just a minute to help you remember those, possibly. We talked about quotient identities last time. Those help you in the unit circle when you're trying to find the value of tangent and value of cotangent. So this is not new. You saw these last time in the last video. Let me show you where the Pythagorean identities came from, and it might help you remember. Because in all honesty, if I just had to be completely honest, I know the first one. I always have to scratch my head on the other two because I know where they come from. So I just figure it out every time. So here we go. Let me just show you where they came from. I know sine squared plus cosine squared equals 1. And by the way, do you see that that fits the mode for a Pythagorean relationship? You have a squared plus b squared equals c squared. And yes, 1 is c squared because 1 squared is 1. So we're fitting Pythagorean. And yes, this is written a little funky because the square is on the trig function. It's not on the angle. So make sure you're putting the square in between the sine and the angle. Okay? Don't put it after the angle. Okay. Watch this. You take this and you just say, oh, okay, let me come in here and divide by sine squared. Divide every term by sine squared. Now use the little things that you know. You know about reciprocal identities, you know about quotient identities, you've seen all that now. Sine squared over sine squared is 1. Well, you know what cosine over sine is now. You just learned that is cotangent. But since they're both squared, this is squared. There's cotangent squared. And 1 over sine, what was the reciprocal of sine? Yes, it was cosecant squared. Everything still remains squared because we're still in Pythagorean relationships. These were all squared up there. Well, there you go. There's one of the other ones. All right, so go back to the original. This time, we're going to come through here. We're going to divide through by cosine squared. Here we go. Now sine over cosine, remember that's tangent squared, and cosine over cosine is 1. 1 over cosine is secant squared. There you go. There's your other one. So whichever way you choose to remember it, maybe you choose to memorize them. Maybe you choose to remember the first one and derive the other two. One way or the other, you are responsible for knowing those. You need to know your reciprocal identities. You need to know, there's 6 of those. You need to know your Pythagorean identities. There's 3 of those. And you also need to know your quotient identities. There's 2 of those. Okay, a lot of work to do, guys.